In the dead of winter, January 1700, a ghost wave slammed into the coast of Japan. It wasn't just a storm surge, it was a monster. It rose out of the dark ocean, flattening villages, flooding rice fields, and dragging entire buildings backward into the sea. By morning, the coast was a ruin. But there was something wrong. This tsunami was completely impossible. Why? Because there was no earthquake. In Japan, the ground and the sea are linked. The people knew that a tsunami is the child of the earthquake. First, the ground shakes violently, and then you run. That is the warning. But on this night, the earth was silent. There was no tremor. No shudder. Just a sudden, terrifying roar of the ocean, attacking the land, seemingly of its own free will. Japanese scholars, samurai, and village headmen recorded the event with meticulous precision, but they were baffled. They called it an orphan tsunami, a wave without a parent. For 300 years, this event was a cold case. The mystery of where it came from remained unsolved. Was it a punishment from the gods? A demon of the deep? Or something far clearer and far worse? The clues to its origin, it turns out, were hiding 5,000 miles away. This is the story of how a geological ghost story, passed down in Native American legends and written in the rings of dead trees, finally gave that orphan a name. And in doing so, it uncovered one of the greatest natural threats facing North America today. Picture the scene. It is late January, the year 1700, along the rugged coast of Honshu, Japan's main island. In coastal towns like Kuwagasaki and Miyako, the winter days are short. The sun has long since set. Merchants have closed their shops, and families are settling in for the night, huddled around charcoal hearths to escape the biting chill. Then, the sea begins to behave strangely. With absolutely no warning tremor, the water simply pulls back. It retreats from the shore, exposing the seabed in a sinister, unnatural low tide. Crabs and fish are left flopping in the freezing mud. Anyone who had lived by the sea their whole life knew exactly what that meant. A tsunami was loading its weapon. Panic erupts. In the darkness, villagers scramble for high ground, shouting warnings to their neighbors, clutching children and heirlooms. Before long, the ocean returns. It doesn't strike as one single curling Hollywood-style wave. It arrives as a series of powerful, relentless surges. A wall of water pushing inland, with the weight of the entire Pacific behind it. And it keeps coming, surge after surge, for hours. The damage was catastrophic. In the village of Kuwagasaki, official records detail the destruction. 13 houses smashed flat by the water's impact. The chaos sparked a fire that consumed 20 more. Further south, in the port of Nakaminato, a ship loaded with 28 tons of rice, a fortune in those days, was tossed like a toy against the rocky shore, killing the sailors on board. Samurai magistrates, monks, and merchants all wrote down what they saw. They documented the salt-ruined fields and the shattered warehouses. The water flooded over 600 miles of coastline, from the snowy north of Honshu down to the Kii Peninsula in the south. But the next morning, as the sun rose over the wreckage, the survivors were left with a haunting question. Where was the earthquake? Japanese seismology was advanced for its time. They kept registers of Jaishin. Earthquakes. They knew the pattern. But this wave had no parent. It was an orphan. Meticulous record keepers noted the time the nightmare began. Around midnight, ushering in January 27th. They wrote it down in official registers, like the Morioka Han Zasho. But because they couldn't find a cause, these records were filed away. A perfectly preserved mystery sitting in the archives. The Orphan Tsunami became a legend, a wave that came from nowhere. But the solution lay on the other side of the world, in a story that began at the exact same moment. Meanwhile, 5,000 miles away, the sun had set hours earlier on the coast of North America. It was roughly 9 p.m. on the evening of January 26, 1700. Here in the dense mist-covered landscapes that would one day become Washington, Oregon, and British Columbia, there were no written records in the Western sense.
History was not kept in books. It was kept in the living memories of the people who had walked this land for millennia. The Yurok, the Maka, the Nuchanolth, the Ho, and dozens of other indigenous nations. And their stories from that time speak of a night of absolute, unimaginable terror. Unlike in Japan, the night here was anything but silent.
According to oral traditions passed down through countless generations, the catastrophe began with the ground shaking so violently it was impossible to even stand. The Yurok people tell of a figure called Earthquake running up and down the coast, his heavy feet making the ground sink and crack.
They describe the earth quaking and quaking again, a relentless, sickening motion that felt like the world was ending. This wasn't a brief tremor. The shaking went on for minutes, perhaps 5 or 6 minutes, a terrifyingly long time filled with the thunderous roar of landslides and the screaming of snapping trees.
In the villages along the coast, the devastation was total. The Huayat people on Vancouver Island tell a particularly heartbreaking story. In the village of Anakla, people had just gone to sleep in their cedar longhouses when the shaking began. The sandy ground beneath them turned to liquid, a process we now call liquefaction.
The massive wooden structures sank into the earth as if it were water. Before they could recover, the ocean poured in. The oral history says the flood followed so fast that people couldn't even reach their canoes before everything was lost and gone. At Anakla alone, it is said that out of 600 people, only one single person survived the night. Entire communities were wiped from the face of the earth.
The land itself, home to generations, suddenly dropped and the ocean rushed in to claim it permanently. While some tribes preserved the memory in heartbreaking physical detail, others encoded the event into their spiritual history.
Further south, the Ho and Quileute people speak of a great battle between supernatural beings, the Thunderbird and the whale. In this legend, the whale was a monster, depriving the people of food. The benevolent Thunderbird swooped down from the heavens, grasped the whale in its talons, and lifted it from the sea. The struggle was so violent that it shook the mountains and uprooted the forests. When the whale was dropped back into the water, it caused a massive wave that swept across the land, changing the coastline forever. For centuries, anthropologists and historians dismissed these stories. They treated them as simple folklore, metaphors, or myths. But in the late 20th century, a new generation of scientists began to ask a different question. What if these were just legends? What if they were eyewitness testimony? What if these stories were a history book, written in a language science was only just beginning to learn how to read? The proof, they would find, was waiting for them in the salt marshes, in the silent, skeletal remains of a dead forest.
Along the misty grey coasts of Washington and Oregon, specifically in places like the Copalis River, there is a strange and haunting sight. If you paddle a canoe out into the salt marshes at low tide, you will see them. Entire groves of massive dead cedar trees, standing like bleached skeletons in the mud.
For decades, these ghost forests were a local curiosity, but a biological puzzle. These are western red cedars, massive, ancient trees that require fresh water to survive.
Yet here they stand, their gnarled roots submerged in salty, tidal muck. A forest cannot simply walk into the ocean.
So, what killed them all at once? In the mid-1980s, a geologist with the U.S. Geological Survey named Brian Atwater began to suspect these trees were a witness to a crime. Atwater wasn't the type of scientist who stayed in the lab. He was a muddy-boots geologist who preferred digging in the tidal slime. He looked at these dead sentinels and felt they were trying to tell him something. As he put it, the trees seemed to scream, "Interpret me. How did I die?" To find the answer, Atwater and his team waited for low tide and sliced into the riverbanks beneath the dead trees. What they revealed was a geological layer cake, a distinct pattern of soil that told a violent story. At the bottom was the dark organic peat of the original forest floor, full of ancient roots and fern fossils.
Resting directly on top of that forest floor was the smoking gun, a clean, sharp sheet of sand. This wasn't sand blown in by the wind. It was ocean sand, transported inland and dumped in a chaotic, messy layer. To a geologist, this meant only one thing. A massive surge of water had rushed over the land, burying the forest floor in seconds. A tsunami. And finally, on top of the sand, lay the thick tidal mud that makes up the marsh today. The sequence was terrifyingly clear. Sometime in the past, the land hadn't just shaken. It had collapsed. In an instant, the coastline dropped by as much as 6 feet. The ocean rushed in to fill the void, burying the forest in sand and drowning the roots in salt water. The trees died instantly, their trunks entombed in the salt, left to stand watch for centuries. The evidence was overwhelming. The Pacific Northwest, long thought to be seismically quiet, had been hit by a megaquake. But geology is messy. The mud could tell them what happened, but it couldn't tell them exactly when. For that, the detectives needed to interview the victims directly. The ghost forests were a crime scene. To pinpoint the time of death, scientists turned to Dendrochronology, the science of reading tree rings. A researcher named David Yamaguchi joined the investigation. He knew that trees are nature's hard drives. They record the conditions of every year they are alive. A wet year creates a wide ring, a drought creates a narrow one. By comparing the rings of the dead ghosts to living ancient trees nearby, Yamaguchi built a continuous timeline, stretching back centuries. He began to count backward, ring by ring, year by year. What he found was consistent across hundreds of miles of coastline. From Washington down to Northern California, the trees all told the exact same story. They showed healthy, wide growth rings for decades. And then, a sudden, catastrophic stop. The final ring on every single ghost tree was complete. It included the latewood, the dark, dense band of cells that forms at the very end of the summer growing season, just before the tree goes dormant for winter. But there was no new growth for the following spring. This was the breakthrough. The trees hadn't died from a slow sea level rise or a gradual disease. They had finished their growing season in the late summer of 1699, and they had died suddenly before the spring of 1700 could begin. The window of death was narrowed to the winter of 1699 to 1700. The science was now lining up perfectly with the Native American stories of a winter disaster. The team had a culprit, a massive subduction zone earthquake. They had a general time of death, winter. But winter is a long season. To prove this was the same event that caused the Orphan Tsunami in Japan, they needed a precise date. They needed a timestamp. Now, the scene shifts back to Japan.
While Atwater and Yamaguchi were working in the American mud, a Japanese seismologist named Kenji Satake was analyzing his own country's history. He was well aware of the mystery of the 1700 Orphan Tsunami. When Satake read about the American discovery, the ghost forests, the tsunami sand, and the winter 1700 date, a light bulb went on.
Could the orphan in Japan and the ghost in America be related? Satake realized that if the Cascadia fault had ruptured, it would have sent a massive wave racing across the Pacific Ocean. He turned this historical cold case into a math problem. Using computer models, his team simulated a magnitude 9.0 earthquake off the coast of North America.
They calculated the speed of the wave, about the speed of a jetliner, over 500 miles per hour. They calculated the distance to Japan.
The travel time would be roughly 10 hours. This was the moment of truth.
Satake, Atwater, and their colleagues went back to the ancient Japanese scrolls, the records from the samurai magistrates and the village headmen. They looked for the arrival time.
The Orphan Tsunami had begun crashing into the Japanese coast on the morning of January 27, 1700. They did the math, counting backward. 10 hours across the dateline.
10 hours before the Japanese morning of January 27th places the origin of the wave on the evening of January 26, 1700 in North America. It was a perfect match.
The time, roughly 9 o'clock p.m.,
explained why the Native American oral histories spoke of a disaster that struck at night after people had gone to sleep. The date, January 26th, sat perfectly in the winter window that the tree rings had predicted. The puzzle was complete. The American ghost forests, the indigenous oral histories, and the Japanese samurai records all pointed to the exact same event on the exact same day at the exact same hour. The orphan had found its parent. The ghost story was real. And the culprit finally had a name. The Great Cascadia Earthquake of 1700. With the mystery solved and the timeline established, scientists could finally step back and look at the true face of the monster. The event that struck in 1700 wasn't a freak accident. It was the breathing cycle of a massive geological engine. Running for over 700 miles, from Northern California all the way up to Vancouver Island, lies the Cascadia subduction zone. It is an invisible seam where the planet is stitching itself together. Think of it as a slow-motion tectonic wrestling match. Out in the ocean, a dense slab of the Earth's crust called the Juan de Fuca Plate is trying to slide beneath the North American continent. But this isn't a smooth glide. The boundary is rough, jagged, and sticky. For centuries at a time, the plates get stuck. They lock together. But the conveyor belt of the Earth doesn't stop pushing. So, as the oceanic plate shoves against the continent, the edge of North America begins to buckle. It compresses like a giant spring being wound tighter and tighter. The coast slowly bulges upward, silent and unnoticed, accumulating massive amounts of explosive energy. This loading phase can last for hundreds of years, until the rock simply cannot take the strain any longer. On that night in January 1700, the spring snapped. In a matter of minutes, centuries of stored energy were released all at once. The North American plate lurched westward over the ocean floor. The coastline, which had been bulging upward, instantly collapsed, dropping as much as 6 feet. This is the mechanism that drowned the ghost fires so suddenly. Simultaneously, the seafloor snapped upward, punching the ocean from below. This displacement lifted a column of water miles wide, creating the tsunami that raced across the Pacific to Japan. The earthquake was a magnitude 9.0. To put that in perspective, a magnitude 9 releases roughly 30 times more energy than the famous San Francisco earthquake of 1906. It is a violence so profound it actually rings the earth like a bell. For a long time we thought the Pacific Northwest was safe, but the ghost forest proved that this silence isn't peace. It is the silence of a bomb waiting to go off. Solving the 300-year-old mystery was a triumph for science. But the story doesn't end in the year 1700. Because the Cascadia subduction zone is a cycle, geologists returned to the salt marshes and dug deeper. Beneath the sand layer from 1700, they found another layer of peat, and below that, another sheet of sand. And another. By counting these layers like pages in a terrifying history book, they found that these megaquakes have happened at least 43 times in the last 10,000 years. The average time between them is roughly every 300 to 500 years. Now do the math. The last one was in January 1700. That was over 325 years ago. We are not just approaching the window for the next great Cascadia earthquake. We are standing squarely inside it. The tectonic spring is fully wound. The stress has been building every single day since the time of the samurai. And today, the stakes are immeasurably higher. In 1700, the Pacific Northwest was a wild landscape of cedar longhouses and seasonal fishing camps. Today, that same coastline is home to millions of people in cities like Seattle, Portland, and Vancouver. When the Cascadia Fault ruptures again, and it will be the worst natural disaster in the history of North America. Seismologists predict the shaking will not last for 10 or 20 seconds, like a normal earthquake. It will last for 4 to 5 minutes.
5 minutes of violent shaking is enough to liquefy the soil, turning solid ground into quicksand. But the water is the true nightmare. 15 to 20 minutes after the shaking stops, the tsunami will arrive. It will not be an orphan this time. It will be a wall of water up to 100 feet high, sweeping into coastal communities that have been severed from the outside world. Scientists estimate there is roughly a 1 in 3 chance of a massive rupture hitting the southern section of the fault within the next 50 years.
Those are dangerously high odds. The discovery of the 1700 event was a massive wake-up call.
It changed everything. It led to new building codes and the installation of tsunami sirens.
If you visit the Oregon coast today, you will see blue lines painted on the streets. They mark the edge of the tsunami inundation zone.
They are a message. If the ground shakes, get behind this line.
But looking at the ghost forests, the question remains, are blue lines and sirens enough against a force that can reshape a continent?
What began as a mysterious orphan wave in Japan became the key that unlocked a terrifying secret hidden beneath our feet. It took a cross-continental, 3-century-long detective story to piece it all together. It required linking the handwritten ink of Japanese scribes, the timeless oral histories of the indigenous peoples who survived the apocalypse, and the undeniable evidence written in the rings of dead trees. We solved the mystery.
We know exactly what happened on that dark night in January 1700. The Cascadia subduction zone isn't a relic of the ancient past. It is a present active threat. It is a geological time bomb, quietly counting down just off the coast where we live, work, and sleep.
The Orphan Tsunami of 17 finally has a name: Cascadia. And while its story solved a great mystery of the past, it also delivered a chilling prophecy for the future.
A prophecy that is still waiting, silently, to be fulfilled.